All right, this is the trig word problems we did on Tuesday, March 5th. Okay. So first thing we want to do is read the problem, and as we read, we'll read it once. Okay, then as we read it a second time, we're going to want to draw it. So number one says a monument stands on level ground. The angle of elevation to the top of the monument taken at a point 405 feet away is 32 degrees. Find the height of the monument. So we have a monument that stands on level ground. Okay, so here's some level ground. Here's our monument. Okay, don't need to make it fancy. It's just a simple obelisk, I guess. Okay, stands on level ground. The angle of elevation to the top of the monument taking at a point 405 feet away. So 405 feet away, the angle of elevation is 32 degrees. Find the height of the monument. So here's our right triangle. Okay, this is the right angle. So here's our monument. The angle of elevation to the top of the monument taken at the point 405 feet away. So here's the monument, 405 feet away, a 32 degree angle of elevation. Okay, we have to find the height of the monument. We'll make that x. So we have the angle and we have the base of the triangle. We're trying to find the height. First thing we want to do is label our sides. So here we're looking at 32 degrees. Across from 32 is the x, so that is opposite. 405 is next to, so that is adjacent. Okay. So opposite and adjacent, we want to use tangent. So tangent of 32 is going to equal x over 405. We have to solve for x, so we have to multiply both sides by 405. 405. These cancel. We get 405 times the tangent of 32 equals x. So 405 times the tangent of 32 is 253.1. 253.1. So that's 253 feet. Okay, our height's 253 feet. I'm just going to round to the tenth place on these, so 253.1. Right, number two. Right, a boy flying a kite lets out 150. So here's a boy. He lets out 150 feet of string. That makes a 64-degree angle with the ground. Okay, if the string forms a straight line, meaning it's taut, how high above the kite is the ground? So how high is the kite? So here's our triangle. We have here's 64. 150 is across from the right angle, so that's our hypotenuse. Across from 64 is x, so that's opposite. We have opposite and hypotenuse, so we're going to want to use sine. So sine of 64 is going to equal x over 150. Sine is opposite over hypotenuse. Okay, so we want to multiply both sides by 150. Okay, so we get 150 times the sine of 64 equals x. 150 times the sine of 64, and we get 134.8 equals x. That is the height of the kite. Okay, number three, a person in a balloon which is 2,000 feet above. So here's a person, 2,000 feet above is a balloon. So 2,000 feet above the airport. Finds that the angle of depression to a ship out at sea, so the ship's out at sea, the angle of depression is 21. Find the horizontal distance between the balloon and the ship. or the distance from the airport to the ship. So the horizontal distance here is the distance from the airport to the ship. Here's our right angle. So across from 21 is x, so that's opposite. The leg next to 21 is 2000, so that's adjacent. So we're going to have the tangent of 21 is going to equal x over 2000. Okay, we want us to get x by itself, so we multiply both sides by 2000. Oops, 2000. Okay, so 2000 times the tangent of 21 equals x. 2000 times the tangent of 21. 767.7 equals x. Okay. Number 4, an airplane climbs at an 11-degree angle from the ground. Find the distance it has traveled when it attains an altitude of 400 feet. Okay, so an airplane climbs, so it starts down here. It climbs at an 11-degree angle from the ground. Okay. Find the distance it has traveled when it is 400 feet off the ground, when it attains an altitude or a height, altitude meaning height, of 400 feet. Right, so hypotenuse is x, and the altitude is opposite. So we're going to use sine. Sine of 11 equals opposite over hypotenuse. Got to multiply both sides by x. So we get x times the sine of 11 equals 400. Divide both sides by the sine of 11. We get x equals 400 divided by the sine of 11. Which is 2096.3 feet. 2096.3 is the distance the plane has traveled if it's inclining at an 11-degree angle. When it's 400 feet off the ground, it will travel 2096 feet. Right, number 5, find the angle of elevation of the sun when a 24-foot tree, here's a 24-foot tree. There's a tree, I guess. Okay. So 24 feet tall. Okay, and it casts a shadow that is 36 feet long. So here's the sun. Okay, it's going to cast light. It's going to cast a shadow, which is on the ground. Right? The shadow is on the ground. Your shadow is on the ground. The tree shadow is on the ground. Okay, we want to find the angle of elevation. So again, angle of elevation is one going up. Okay, so we'll call that theta. So we're looking at theta. Across from theta is opposite. Next to theta is adjacent. So we're going to use tangent. We want to use the inverse tangent function because we're finding an angle measure. So inverse tangent is going to be 24 over 36. So inverse tangent of 24 divided by 36 is going to give us 33.7 degrees. Okay, number 6. A 40-foot ladder is leaning against a building. So here's a building. Okay, so we're leaning a 40-foot ladder. So here's our ladder. It's 40 feet long. Okay, the foot of the ladder, meaning the base of the ladder, right? Your feet are on the ground. So the foot of the ladder is the base. Is 32 feet from the base of the building. Find the angle that the ladder makes with the building. So the ladder and the building make an angle up here. So here's the angle in question. 40 is our hypotenuse. Is 32 across from or next to? It's across from, so that's opposite. So it's opposite and hypotenuse, which means we want to do sine. So sine of theta is going to equal 32 over 40. Okay, but we want to find the angle, so we want to use the inverse sine function. Okay, and that's going to be 32 over 40. That's going to give us theta. Okay, so the inverse sine of, what is that, 7 over 8? 32 divided by 40, 53.1. Four over 5, I don't know what I'm thinking. Okay, our angle is 53.1. Okay, number 7. The television tower is 150 feet high. So again, it's 150 feet up. Okay, and an observer is 120 feet from the base of the tower. Find the angle of elevation to the top of the tower where the observer is standing. Okay. Angle of elevation from the top of the tower to the top of the tower from the place where the observer is standing. So here's the tower. It's 150 feet tall. The observer is standing 120 feet away. So the angle of elevation from where he's standing is theta. Okay. So we have opposite and we have adjacent. So we want to use tangent. We're finding an angle, so we want to use inverse tangent. So the inverse tangent of opposite over adjacent, so that's 150 over 120, is going to equal theta. So we put that in the calculator. That is 5 over 4. I'm putting in 150 over 120 just to make sure. Okay, and we get 51.3. Theta equals 51.3 degrees. Okay, number 8, last one, we have a 40-foot ladder. This is leaning against a wall. So here's a wall. We have a 40-foot ladder leaning against the wall. Here's my ladder. It's 40 feet. Leaning against the wall. It reaches at a point that is 36 feet from the ground. So here's the ground. So that's going to be 36. Find the angle the ladder makes with the ground. So the angle the ladder makes with the ground. This is opposite, and the 40 is the hypotenuse. So we're using sine. We're doing inverse sine because we're finding the angle, and that's going to be 36 over 40. So the inverse sine of 36 divided by 40 is going to be 64.2. 64.2 degrees. Right, and that is the first trig word problems assignment. We'll do another one tomorrow. 14 and a half minutes.